Okay, so let's start off just doing a simple multiplication rule problem. All right, so I roll a die 6 times, and what is the probability that while I roll it, when I roll it those 6 times, that it never comes up 1? It always comes up as something else other than 1, like a 2 or 3 or 4. What's the probability that it never comes up 1 when I roll it 6 times? Go ahead, and I'm going to give you guys like 15 seconds to think about it, and then I'll take a vote. All right. Elisina, can you put your hand down, or did you have a question? Okay, so raise your hand if you think it is A. All right, raise your hand if you think it is B. Oh yeah, you guys can't see. All right, what about you guys? You guys think it's B? Okay. All right, thank you, Emma. Go ahead and put your hand down. Raise your hand if you think it is C. All right, and anybody for D? Okay, so yeah, the answer was B. We're going to talk about it a little bit. The basic idea is that think of this fraction right here as the first of these 6 times I roll the die. All right, the first time I roll the die, there's a 5 out of 6 chance that it does not land on 1. There's only a 1 out of 6 chance that it does land on 1. All right, on the second roll, likewise, there's a 5 out of 6 chance, and on the third roll, and so on for all of these 6 rolls. And so the probability that it lands up as something other than 1 on all 6 of them, the way we get that is we're just going to multiply these all together. All right, that's how the multiplication rule works. And let me write it out in a way that might be helpful to you guys. So I'm going to go ahead and erase this for the time being. All right, the probability that event A and event B and event C happens, all right, that would be like the probability that I roll a non-1 on both the first roll and on the second roll and on the third roll. That's A, B, and C. That's going to be equal to the probability of A times the probability of B times the probability of C. All right. Now I want to show you guys another way that I hope will make this really clear to you guys. So I'm going to stop sharing my screen, and I'm going to share it again. We're going to go into good old Paint. All right, so let's say that I roll a die 4 times now, making it a little bit simpler. But what's the probability that when I roll it these 4 times, I roll this normal 6-sided die, I take and I roll it 4 times. What's the probability that on roll 1, the die lands on an even number, like 2, 4, or 6? All right. But then on roll 2, it lands on either 5 or 6. And then on roll 3, all right, it's some number that is less than 5. So it lands on either 1, 2, 3, or 4. And then on roll 4, it lands specifically on 2. All right, so it's kind of a mouthful, but I roll the die 4 times, and what's the probability that when I do, the first one will land on some even number, the second one will land on either 5 or 6, the third one will land on some number less than 5, and the fourth time I roll it lands specifically on 2. So what's the probability of getting all 4 of these things to happen? All right. Now, as I just said, all right, the probability that the first thing happens and the second thing happens and the third thing happens and the fourth thing happens is just going to be equal to each of those individual probabilities multiplied by each other. All right. So let's go ahead and do that. What is the probability that when I roll the die the first time that it lands on an even number? Well, there's 3 different ways it can land on even number, as either as a 2, 4, or 6. All right, and there's 6 total possible outcomes. So there's a 3 out of 6 chance, or a 50% chance, that I roll an even number on the first roll. On the second roll, all right, there's 2 different ways that I can roll a 5 or a 6. Either I roll a 5 or I roll a 6. So there's 2 ways out of 6 possible in which I can roll a 5 or a 6. All right, what's the probability? All right, if I roll a die 1 time, what's the probability that it'll be less than 5? Well, there's 4 different ways I can get it to be less than 5, either with a 1, 2, 3, or 4. All right, but there's 6 total possible outcomes. So the probability of rolling the die and it being less than 5 is going to be a 4 out of 6 chance, or about a 67% chance. All right, and what's the probability that when I roll a die that it comes up as 2? It's going to be a 1 out of 6 chance. All right, and so if I roll a die 4 times, what's the probability that all of these things are true at the same time? That the first one comes up even, that the second one comes up as a 5 or 6, that the third one is less than 5, and that the fourth one is 2 specifically. I'm just going to multiply these all together to get, all right, that true? Yeah, 24 over 36 squared. I gotta calculate what 36 squared is. I'm guessing 256, but I gotta double check. Oh, no, that's way off. 1,296. All right, and if we put that in our calculator, all right, if we put that fraction in our calculator, we would get 0.0. It'll be about 0.02. All right, I'm rounding here. And so what that means is there's a 2% chance that if I roll a die 4 times, that the first time it'll be even, the second time it'll be a 5 or 6, the third time it'll be less than 5, and the fourth time it'll land on 2 exactly. 2% chance of that happening. All right, can I get a hand raise if we are following along, if we at least understand how to use the multiplication rule? All right. Does anybody have any? Go ahead and unraise your hands. Are there any questions on the multiplication rule? Okay, if you have questions, I'll stay on the line after everybody else leaves, and you can ask me. All right, let's talk about why this multiplication rule works. So let's say I flip a coin. Flip a coin 3 times. All right. How likely? How likely will I roll heads on the first one, then a tails, then a heads? All right. Now, if we're using the multiplication rule, we're just going to simply multiply each of those probabilities. So on the first one, what's the probability I get a heads? 1 out of 2. All right, and then if I go again, what's the probability of getting a tails on the second flip? 1 out of 2. All right, a 50% chance. And on the third time, what's the probability that I get heads on the third one? 1 out of 2. All right, and if I multiply those all together, I will get 1 out of 8, and we want to keep that in mind. All right, so what I'm going to do is I'm going to show you guys why this multiplication rule works, why it is true, and I'm going to show you this by mapping out the sample space. So when you flip a coin, right, it can either be heads or tails. Now, what I'm going to use right here is called like the tree method or the forking method. All right, where basically it works like this. If I were to flip that coin again, I have 2 options, heads or tails. All right, and if I were to flip the coin a third time, I still have those same 2 options. What I've just done is I've made the sample space, even though you may not see it. I'm going to go ahead and bring that, show you what that sample space looks like. All right, you guys see how it works? The one fork we can take is heads all 3 times. That's what we have right here in number 1. Another one is it could be tails all 3 times. That's what I have for number 8. But see, you could also go heads, heads, and then tails on the last one. So I have that as the second possibility. I could also go heads, then tails, and then heads. All right, that's my third possibility. So we have, what this does is it maps out all the different possible outcomes. And because we're dealing with a coin, each of these outcomes is equally likely. I'm just as likely to get heads all 3 times as I am to specifically roll a heads and then 2 tails. All right, so I'll say this again. All I've done is use this tree method to map out all of the different possible outcomes when I flip a coin 3 times. All right, can I get a hand raise if this is making sense? How I'm coming up with these outcomes. All right, are there any questions on it? All right, so let's go back to that 1 out of 8 figure. All right, I got that just by multiplying these fractions or these probabilities together. But you could also get it by looking at the sample space. So the question was, all right, how likely if I flip a coin 3 times that it comes up as heads, tails, heads? Well, there's one way in which it does that. This one right here, right? There's that heads, tails, heads. But that's one way out of 8 possible outcomes. So a 1 out of 8 chance. All right, and if we put 1 divided by 8 in our calculator, we will get 0.125. All right. So roughly a 13% chance that when you flip a coin 4 times or 3 times that it'll come out specifically as heads on the first one, tails on the second, and then heads on the last one. All right. Let's look at one more and then we'll call it a day. Oh, okay. Okay. So there's a slot machine at a casino that wins on average 1/4 of the time. All right. So if you play this slot machine, you have a 1 out of 4 or a 25% chance of winning. If you play the slot machine 2 times, what is the probability of losing both times? All right, it could be A, B, C, or D. So go ahead and I hope you guys are calculating this at this point. I'm gonna go ahead and quiz you guys on it in like 30 seconds. All right, can I get a hand raise if you think it's A? All right, can I get a hand raise if you think it is B? All right, can I get a hand raise if you think it is C? All right, can I get a hand raise if you think it is D? All right, yes, you guys are right. It's going to be D. All right, and the one way you guys probably did it was you probably did the multiplication rule, which means that you've worked out the multiplication rule. All right, so you have a 3/4 75% chance of losing on the first one, and a 3/4 or 75% chance of losing on the second turn. So if you multiply those together, you'll get 9/16, which is going to be equal to 0.56. All right, or 56%. The other thing you could do is instead of doing the fractions, you could do the proportion, 0.75 times 0.75, and that also will be equal to 0.56. The one thing that you don't want to do is you don't want to kind of work with percents and put in 75 times 75. All right, because if you do that, you're going to get this as your answer. All right, so don't put it into your calculator like that. Do either the fraction form or the proportion form. Okay, so I'm going to kind of just show you guys how we would do this using that tree method like I have right here. I'm going to try and do it really quick. Not too quick, but semi-quick. With the heads and the tails, each of those is equally likely. So it's okay that you have just one going to heads and one going to tails. You cannot do that with the slot machine one though, because you are 3 times as likely to lose as you are to win. And so because of that, you have to draw it out like this, where for every 1 win, you have 3 losses. So notice that if we were to do it this way now, all right, let's say you play it once. What's the probability that you lose? Well, how many outcomes do we have? We have 4. And then how many of them are we losing? 3. All right. And what's the probability that you win if you play it one time? Well, how many outcomes do we have? We have 4. And then how many of them do we win? 1. Okay. Now, just as, oh, dang it. You guys can see what I'm doing. The other people can't see what I'm doing. I forgot to share my screen. All right, guys, hold on just 1 second. Alora and Alok, did you still have a question?
No, sorry.
Okay, no problem. All right. Sorry, I was doing work on Paint and I forgot to share that screen with you guys. Okay, and so what I was saying to at least the people that are in class with me is we can't just have 2 roads like we do with the heads and tails. We have to have 4 of them because we have to illustrate the fact that with these casino slot machines, you're 3 times as likely to lose as you are to win. So we need to have 3 L's for every 1 W. And so if we play once, we'll see how this works out. We'd say it's like we have 4 different outcomes. All right, and what's your probability of losing? Well, there's 3 different ways out of those 4 of losing. So you have a 3/4 chance of losing, or 75% chance. Likewise, what's your chance of winning? 4, we have it as 4 outcomes, with only 1 as winning. So a 1/4 or 25% chance of winning. Now, if we were to move it on to how I had it in the question, which is you play twice, what's the probability of losing both times? I'd have to continue using this tree method just like I did here. All right. So it's going to look something like this. This is going to be really hard for me to do. All right, I'm just going to put that right there. Hopefully you guys can still see those. Okay, so if we look at these, if we count them all up, we have 4, 8, 12, 16. So 16 total outcomes. And in how many of those outcomes do we lose both times? I'm going to cross out the ones where we don't lose both times. So on this one, we lose the first time, but we win the second time. So I'm going to cross out that outcome. The same thing with this one. And the same thing with this one. We have to cross out all of those outcomes. And then we also have to cross out this entire thing because on this one, we won the first time. All right, but I'm asking, in how many out of these 16 do we lose both times? And so after we've crossed out all of these different possible outcomes where you win at least once, we add up what we have left. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, or 9 out of 16. All right. So we have to sometimes adapt that tree method that I used before to map what's called our sample space if these two things, if winning and losing, aren't equally likely. But notice that this 9 out of 16, that's the exact same answer that we had before, where you guys probably used the multiplication rule, where you said you got a 75% chance or 3/4 chance of losing each time, and I just multiply those two together. That would equal 9 over 16, which is equal to 0.56 or 56%. All right, I tried my hardest to make this not take that long, but it looks like we're getting into a half-hour territory. So I'm going to go ahead and stop right there. Does anybody have any last questions? All right, well, you guys have been great. Enjoy the rest of your day, and I'll see you guys on Thursday. All right, take it easy, guys.
Bye.
Bye, take care. Hey, Alok, did you have a question? You might be muted if you're trying to talk to me.